Okay, so probability is the chance that something will happen. So one way to define probability is what we want to have happen sometimes is called the favorable outcome. So probability of something happening would be the number of favorable outcomes, or what we're counting to have happen, divided by the total number of possible outcomes. Okay, so this pertains to some of the stuff we've just been talking about. Like, here's some examples of items that you can use that to test or play with probability, or things like dice or spinner. If I throw this die, it's not even going to show up very well on my video that I'm making, but oh well. What are the chances that 3 came up for me? What's the chance that I got a 3 instead of something else? So how many sides does a cube have? 6 sides. Good. So there are 6 different possible faces that the cube could land on. So the probability that it actually landed on a 3 like that would be 1 side out of the 6 sides, correct? So to write that down, we can write it as a ratio, as Spencer mentioned earlier. So that would be 1 out of 6. But there's also 2 other ways to write probabilities. So a fraction or a ratio is one way to write it. What are some other ways to write a probability? As a decimal. How do you turn a number like 1/6 into a decimal? Yeah, so we've been doing that a lot lately, where we find a number by dividing it, find the decimal by dividing it. So we can just go 1 divide 6 and get the answer. Everybody do that for me, because I want to know you're all awake and you're all got a calculator in front of you. I want you all to do 1 divided by 6 on your calculators. 1 divided by 6, and then show me when you've got it. Hold it up so I can see that means you've got it. I might be able to see the number, I might not be able to see it, but at the very least I can see that you did it. Once you've shown me, you can put it back down. Tila, Brenda, and Alejandra, do you guys have done for me 1 divided by 6? Oh yeah, I've got 2 of you. Brenda, where's yours? Okay, good job, good job. I think that was most of you. So what did you get? 0.1666666 repeating, right? So we can either put the line over the top to say it's repeating, or we might want to just round it. What does 6 round another 6 up to? 7. Yeah, so we might want to just write that as like 0.167. So that's a decimal. That's another way to write a write a probability. The other way is to write it as a percentage. So when you're doing a percentage, you take the decimal and you just simply multiply it by 100. And what that does is it moves the decimal over 2 places. So what would the percentage be for this problem? Austin? 16, and we could even put the 0.7 in there if we wanted to. 16.7%. Is that a great probability that I'll get a 3? What about the probability of getting a 6? It's the same. What about the probability of getting a 1? It's the same. That probability is not very good for any of those numbers, right? Now, if we can increase the probability if we don't care about one number, but instead maybe it's fine to get 2 different numbers. I think there's some games that if you get either one number or the other, I don't know, Parcheesi, is that one of them? You guys ever played Parcheesi? Where you can get a little man out of the place where it's waiting to take its turn around the board if you throw a 1 or a 6. I'm not sure if it's Parcheesi or not, but there's some games that are like that. So how does that change the probability if we're okay with either having a 1 or a 6? How far up does it go? What will the probability be? It would change it, so now we have, if we get a 1, that's 1 out of 6, but if we get a 6, that's another 1 out of 6. Doesn't that give us a 2 out of 6 possibility instead of a 1 out of 6, right? So what will our probability be to get either of those numbers instead of a 3? The first thing you should know is that you should always reduce your fractions if you can. So does 2 6 reduce? Yeah, it reduces to 1/3. So always reduce it if you can. And then let's just practice doing our decimal. So we go 1 divided by 3, And we get 0.33 repeating. And then we multiply that number by 100. So what's the chance? 33.3% chance, right? Did that increase our chances of getting the number we wanted to get if we don't care about it being one of two numbers instead? Yeah. Right, okay. The third one here, what is the probability of getting a 2 on this spinner? Notice on this spinner, each of the sections are the same size. So each one is a fourth of the area of the circle. So here's, the spinner has a 1 here, a 2 here, a 3 here, and a 4 here. What's the chance that it'll land on the 2, since it's all 4 of them are equal areas? Angel? Yeah, it'll be a fourth. 1 out of 4 chance because it's one little piece of area out of 4, right, of the same size. 1/4. So what decimal or percent would that be? 0.25 or 25%, right? So that's the type of probability you probably did in a previous math class. Do you remember doing that kind of probability in a very earlier math class? Okay. In geometry, we extend our probability to geometric shapes. So this already was kind of a geometric shape where we were talking about areas of a circle. We're going to do more of that type of thing. Another thing we sometimes use to figure out probabilities is segments. So here I have some segments. We're going to practice the probability of picking a random point between two other points. And so how many points are on a line? I mean, not just the little ones that are marked. How many numbers can we name on a line between 2 points? Aren't there like infinitely many? Yeah, so is there any way we could actually do a number over a number? If there's infinitely many of them? Not really. So instead of using a number of numbers divided by another number of numbers, since there's infinitely many numbers, instead sometimes we use distance or area instead. You guys getting this? Hasil, Gloria? Okay, so sometimes instead of it being a number of outcomes, it'll actually be length or area. So like later we're going to deal with area and we're going to do shaded area over total area. Because we can't really count that as the number of something. It's actually just it's an area. It's different than that, right? It's different than just having a number of sides on your die. Okay, so let's look at these examples with our segments here. Let's go through one of them together and then I'll give you a chance to do the others on your own. And I'll come around and check and make sure you're working. I'm only going to do one of them with you, and then you have to do the other 3 on your own, so you ought to be listening. Okay, so the question says, what is the probability that a random point on each segment, AB, will be between C and D? Let's do the first one together. The first one says we have AB is from -3 to 6. CD is just from 0 to 3. We want to know if we pick a random point between -3 and 6, will that random point be between 0 and 3? What are the chances that it will be? Okay, so what we want to do is we want to do the length of CD on the top of our ratio, and then we're going to do the length of AB on the bottom of our ratio. Okay, so how long is CD if C starts at 0 and D ends at 3? How long is CD? From 0 to 3. It's a length of 3. Good. And then how far is it from -3 to +6? Ah, I finally heard it. So a lot of people said 6, but it's actually 9 because it starts back at -3. Do you remember how to find distances like that? We learned it at one point where you can just take the two numbers and subtract them. Like I think we used A and B and we said we could subtract those and do the absolute value. So what number is next to A? It's a -3, right? What number is next to B? It's a +6. So let's take those two numbers and subtract them. That gives us a -9. But distances are always positive. So the absolute value makes that answer positive. How long is AB? AB is 9 in length. Okay, now what should we always do with our fractions if we can reduce them? We should reduce them. So this answer would really be better as 1/3, or again, that would be 33.3%, correct? So what I want you to do is take a minute to do the next 3 problems, find the fraction and the percent for each one. Go ahead and do that.